So now to continue, we've just finished sketching this for the the rectangles for each type, the left, right, and Riemann sum. So now we're gonna actually go on and approximate the area of each Riemann sum. Okay. So let's start with the left Riemann sum over here. So to find the area of the left Riemann sum, so area, we know that the area of all four of these rectangles would be simply the area of the first rectangle plus the area of the second rectangle plus the area of the third rectangle plus the area of the fourth rectangle, right? Pretty simple. So let's talk about the area of the first rectangle. We know generally the area is going to be some length times a width. And in this case, I'm going to just leave the length blank for now. But we know that the width of each rectangle, and especially this first rectangle, is 0.5. Now, how do we find the length of this rectangle? Well, clearly we can look at it with our eyeball and see that it's 7 right there, right? So that's pretty simple, 7. But, well, let's look at the next one, the next rectangle. Look at this height, and then this height, this height. This may be 6.2, but that's just a guess. How are you going to figure out for certain the rest of these rectangles? So I guess I can leave that as 7 times 0.5, which we know is 3.5. But how do we figure out the next area? So to find the second rectangle, I'll color it green. To find the area of the second rectangle, we know that width is 0.5. But we don't know what this length is, or I might even change this length to a height, because in this rectangle it's very vertical. Now, how do we find the height of this rectangle? Well, the key is that we are given a function, and do we know how to find the height of any function? Isn't it the y value, or the output of a function? And so all we got to do is figure out what is the input, the x value, for this specific rectangle to find the height. And we know that for a left Riemann sum, right here is the height, and that's going to be for an x value of 1.5. So we know that the height for area 2 is going to be the function of 1.5, right? And we have our graphing calculator here on the left, and so what I'm going to do is I'm going to make a plot so I don't have to retype this over and over. And I'm going to change the table set. So here we go. Here's a table. So let's just double check for the first height for area 1. We know that it's 7, but just to double check, I know that the height for this rectangle is going to be the y value for when x is 1. So we should get 7. See, there you go. There's 7. And so what's the height of area of the rectangle 2? It's going to be the value when x is equal to 1.5. And there you go, 6.25 is the height of area 2. Okay. Area 3 is going to be f of, so what's going to be the height of this one? It's going to be the y value when x is equal to 2. So this is f of 2 times 0.5. And area 4 is going to be f of what? F of 2.5 right here. Times 0.5. And those And there you go. So there you have it. We have all 4 rectangles here with their respective values. And so why don't I just plug in what these are? We know that f of 2 is 5. So this is 5 times 0.5, which is 2.5. We know 6.25 times, let's just exit this and go 6.25, and half of that, oops, is 3.125. And for the final one, we know f of 2.5, if I go back to my table, f of 2.5 is going to be 3.25. So we know it's 3.25 times 0.5, and that gives us 1, just to double check, 3.25 times 0.5 is equal to 1.625. And so when we add it all together, I'll just kind of show it here. And we add them all together, so the total area is going to be 3.5, oh my goodness, 3.5 plus 3.125 plus 2.5 plus 1.625, and that'll give us a total value of 10.75. Okay. Now to speed up the process a little bit, I just want to show you maybe a different way to see this. So if I were to put it all together, I would say the total area is equal to 0.5, which is the width, times the f of the 7 was the f of 1, plus 0.5 times the f of 1.5 plus 0.5 times the f of 2 plus 0.5 times the f of 2.5. Do you see a little pattern here? We can factor out what they all have in common. We know that 0.5 is what they all have in common, and we multiply it by the f, I'll do a bracket here, f of 1 plus the f of 1.5 plus the f of 2 plus the f of 2.5. And that's another way to think about this problem. Okay, so I'm going to use the same idea to calculate the right Riemann sum. So I'll make a new text box. Okay, so let's use that same idea for the right Riemann sum. We know that the total area, just like before, is going to have this 0.5 times the 4 different heights, right? Just like here. Here's the height 1, height of the first rectangle, height of the second rectangle, height of the third rectangle, height of the fourth rectangle, all multiplied by the same width because they have the same width, right? So our question here now is, what are the heights of each rectangle? So let's start with this first rectangle. We know that the height for a right Riemann sum, remember, the height is the right side of the rectangle. That's the height. Okay, so what's the x value here? The x value is 1.5. So the height is going to be the f of 1.5 for this first rectangle. The f of 1.5. Change it into brackets. So how about the next one then? The next rectangle, the second rectangle, is going to have a height of 2. So f, or not height of 2, but the x value is 2. F of 2. And the next one is f of 2.5. And finally, the last one is the f of 3. Okay? So comparing the two, this is the right side, this is the right, and this is the left. Okay? Very similar but different in that we're looking at the heights of the right side of the rectangles. Okay. And so what it ends up being is equal to 0.5 times the f of 1.5. We saw 6.25 plus the f of 2 is 5 plus the f of 2.5 is 3.25 plus, and we haven't figured out this last one yet, but if we plug 3 into our calculator, we get 1. And hey, you see 1 right there? There's that height. It makes total sense. And so you can do, if you do all the math, plug it in the calculator, you'll get the answer 7.75. Okay? So there's 10.75 for the first one, and 7.75 for the second one. Okay, let's do our midpoint. Same exact thing. So I'm just going to copy paste. Same exact thing, except we have different heights. So what do you think are going to be the heights in this case? Remember that green line right here? Remember how we said the midpoint is the height of the middle of the rectangle? So what do you think the x value of this middle part is? Here's 1, here's 1.5, this must be 1.25. So it's the f of 1.25 plus, what's this one? This rectangle is going to be, here's 1.5, here's 2, 1.75 plus f of 2.25 plus the f of 2.75. And I'll let you figure out this middle line to double check your work, but the answer to this one is going to be 9.375. So there you go. Here's how you do the first part of the notes. And so let's do a little quick summary. I have these questions for you guys so you can to help you think about this problem. So let's recall, how do we figure out the width of each interval? How do we figure out there's 0.5 here? Well, we knew that the interval is from 1 to 3, right here, and that it was going to be 4 subintervals. That's the key. And so one quick way to think about it is, what you can do is you find the distance between 1 and 3, and what is the distance between them? Isn't it 2? So I'm just going to put the distance between intervals. And then what do we do with the subintervals? Let's say, so we wanted 4 subintervals, so we found that the distance was 2, and if we divide it into 4 parts, we're going to basically do a division, right? We're going to divide it by the number of subintervals. The number of subintervals, right? And for our case, the distance was 3 minus 1, right? These are the 2 intervals, and then we divided by 4, which is 2 over 4, which is 0.5, right? And that's how we figured it out. And this is nice because sometimes you're going to be asked to find subintervals of, I don't know, maybe like 5, and how are you going to figure out from your eyes, like how do you do this? If you use this quick formula, you find the distance between the intervals and divide it by the number of subintervals, you can get a answer for the width every time. And finally, how do we figure out the length of each subrectangle? So for a left Riemann sum, we looked at the left height. For a right Riemann sum, we looked at the right height. And for a midpoint Riemann sum, we look at the middle height. And there you go.